Hi everybody! In this video, we're going to learn how to set up a simulation where our mobile host communicates with each other wirelessly. This is going to be done using INET's standard host in OMNET++, and we're going to do this in steps. So first we're going to learn how to make two static hosts communicate wirelessly. Then we're going to apply the visualizer onto our code, and then we are going to then make our host move so we can see how a mobile host communicates with INET's standard host. So let's get started. First, we're going to set up our simple simulation. As I said before, this is going to have two static hosts that communicate wirelessly. We're going to create a network that contains two hosts, and one host is going to send a UDP data stream wirelessly to the other. The goal is to keep the physical layer and the lower layer modules as simple as possible. That way we can expand on the network as we move along. So I'm going to make a new folder in my simulation and call it wireless network. And in this folder, I'm going to create a new file called wirelessnetwork.net. And this is the source of our network. We're going to make our wireless network net file have one item in it, and we'll click finish. So now our new wireless network net file has been created, and it's in the correct package as well. The one item is the declaration of our network. So let's add some simple modules to this network. As I mentioned before, we are going to make a network that connects two hosts together. So we need to declare our host and the network. There are parameters. We're not going to set any parameters right now. So our parameters is going to be empty. And then we have submodules. So the first thing we're going to add is our network configurator. First module we're going to add is our configurator. So this is going to be configurator, and it's going to be our IPv4. So the IPv4 network configurator assigns our host IP addresses. In order to access the IPv4 network configurator, we need to import in that INET library. So we write import INET, and the IPv4 network configurator is under the network layer. So INET network layer dot configurator dot IPv4, and then the name of our configurator. You do not need to memorize this. You just go looking for it, or use another template such as the wireless network that we're going to be making right now. You can use this template when you're making your own project. The next thing that we need is our radio medium. Our wireless simulations inside INET need this radio medium module because it represents the shared physical medium where all of our communication takes place. So it's responsible for signal propagation, attenuation, interference, and other physical phenomena that can be brought up. So we're going to add a very simple radio medium. So let's say we want to interchange our radio mediums. So there are several different types of radio mediums in INET. For example, there is unit disk radio medium, and then there's also unit disk radio and a bunch more. So we could maybe want to change what our radio would be going forward. So we can actually say that our radio medium is like a specific interface. So we can say radio medium, and then we can give a default. And let's say our default is unit disk radio medium. And it's like iRadio medium. iRadio medium is the interface for radio medium. So now we need to make sure that we import in iRadio medium. iRadio medium lives under the INET physical layer in the contract packet level. So we have the configurator that's going to assign our host IP addresses, and we have the radio medium, which is going to work for our hosts to communicate with each other. So the only thing we need to add are our hosts. So we're going to add two hosts. We're going to have host A and host B. So we're going to call this host A. Host A is going to be a wireless host, and host B will be a wireless host as well. So wireless host lives under our INET nodes. So here is our network. It has the configurator, the radio medium, and our two hosts that are going to communicate with each other. So we have set up the network, but we need to change some parameters so that they can all talk to each other. If you wanted to, you could go over to your design tab and you can see how our network is set up. Here is the configurator, the radio medium, and since I moved the radio medium, I'll show you in a second what happens, but if we move our items around, we've actually changed the display location. So the display gets updated with its point on the design map. You can even change the square and how big it is as well. So that changes this, and that now adds it as a parameter for our overall network. So we want to change where our hosts are. So in this case, what I'm going to do is make our playground, which is that gray square that we saw earlier, be 600 by 600. So I want it to be 600 by 600. And I want to have our two hosts be spaced out by 400 meters apart from each other. So I can say our wireless host A starts at 50, and then wireless host B goes at 450. Now they are 400 meters apart and they're on the same line. If we go back to our, and add a little code block, right? So now if we go back to our design, here is our overall, we have our host A and host B are 400 meters apart. This is useful because we're going to actually change our communication range, and you can start seeing where the overlap is. So we have set up our network. Now we need to set up our configuration file, or the OMNET++ INI file. So we are going to make a new initialization file. It's OMNET++ and INI, and we can just make an empty INI file. So this is our empty INI file. It created a general configuration for us by default, and the network is empty. Our network is wireless network. So now we are going to be initializing our wireless network. You can even add a description. So if we wanted to, we can say description, and this will be simple sim where two hosts communicate wirelessly. And you can set the sim time. So let's say that we don't want this to run more than 30 seconds. So we say sim time limit, and we can set it to 30 seconds. So now our simulation will only be 30 seconds long. So we have a little bit of housekeeping that we have to do. We need to set up so that our hosts have their IPv4 parameters set properly. The host A is going to be communicating to host B via UDP. So we also need to set up the application being UDP. So let's add those items. First, let's update our host. So I'm saying for all of the network, so that asterisk all, I want to say for host, and now you can do a wildcard on your host. So if I do host asterisk, this is going to change host A and host B. Asterisk IPv4, we're talking to the within the wireless network. So if we go back to our wireless host A, they are going off of wireless host. Wireless host extends standard hosts, and within that it has an IPv4 setup. So IPv4, we're going to set the ARP type name, and it's suggesting it to me, so instead of typing it all, and we're going to set this to be global ARP. The host have to know the MAC addresses in order to communicate, and our IPv4 configurator is helping us by using our global ARP modules instead of a real ARP. Let's define our host A parameters. To add a comment in your INI file, you can do a hashtag and say host A configuration. So we're going to set up host A's number of apps and also set up the UDP connection. So asterisk, which means everything under that network, we're going to access asterisk dot host A. We're going to access now host A, and we're going to set the number of apps to 1. Then we're going to set up our application layer to make it equal to UDP, make it so that host A's destination address is host B. They are going to be communicating on the same port. We're going to set this port to 5000, and it's going to send a 1000 byte message. And it's going to send this every 12 milliseconds. So host A has been set up with the type main being UDP basic app. Its destination address is host B. The destination port is 5000. Message length is going to be 1000 bytes. The center interval is 12 milliseconds. And the packet name, this is just for identifying the packet, is going to be UDP data. Now let's set up host B. So we want to set up host B's number of applications, and it's going to also have its local port set to 5000 so that the destination address and the destination port are the same as the local port. And it's going to use our UDP sync. So here's our host B with the number of apps being 1. The app's type is UDP sync, and its local port is 5000. So now we have set up our hosts to talk to each other, but they have to communicate through our wireless LAN. So we need to set up the wireless LAN properties. So again, like we did with our host for all hosts, we're going to do the same thing here. So asterisk dot host asterisk. We're going to say the wireless LAN. We only have one. That's 0. Its type name, and we're going to make this our ACking wireless interface. Basically, at this point, we are setting up our radio and how they communicate with each other. So we're going to set the MAC rules. We're going to make it where it doesn't use ACK and it doesn't have full duplex. And then the radio itself is going to have a communication range of 500 meters. So our host should overlap. And we're going to make it, for this simple simulation, ignore interference. So this is now the configuration for our wireless LAN. We set it up to use the ACking wireless interface, and we've set our communication range to be 500 meters. We're ignoring interface, and we also set our MAC header length to be 23 bytes. Last thing that I want to do is set up our bitrate. So we're going to go hosts, so asterisk dot hosts. For all of our hosts, they're going to have their bitrate, and we can access everything that sets up bitrate here. We're setting the bitrate to 1 megabyte per second. So now we are ready to run our simulation. So we're going to right click and we're going to run as an OMNET++ simulation. So now we have our wireless network as we set up before with the playground side. So this is the display and our 2 hosts that will communicate with each other. All the modules have been initiated. So let's run the code and see what happens. So we have host A sending a UDP signal to host B. As you can see, the radio medium is showing when it's receiving packets, when it's listening in. So you can see how we are communicating between hosts in OMNET++, and we're doing this with just our standard hosts. If we speed this up because it's a little slow, we get our simulation time has been reached. At the end, we've done 30 seconds. And you can see that we have a final count of everything that has happened. And wireless network host B received 2,424 packets. So let's close this up and now learn how to add visualization to our simulation. So we go back to our wireless network. We're going to add a visualizer. In this case, we're going to use integrated canvas visualizer, which is a compound module that contains a bunch of typically useful visualizers for our submodules. So we're going to say visualizer, and we're going to add the integrated canvas visualizer. And we're going to import in our integrated canvas visualizer. So that is under import INET visualizer, integrated canvas visualizer. Now keep in mind for these modules, I did show you how you can say it's like a specific interface. Integrated Canvas Visualizer is one of the implemented versions of Integrated Canvas Visualizer. So you could always say default Integrated Canvas Visualizer like Integrated Canvas Visualizer. Both are fine, and if you want to be able to change the visualizer in the future, that might be the way that you want to go. This is all we need to do. Now we need to add the visualizer configuration in our INI file. So go back to our INI file, and we're going to add some configuration. So I'm going to add a comment here and call this visualizer configuration. So we're going to set up our visualizer so that we can see our communication range for both of our hosts. And we're also going to show the signals and display the links. And as well, we're going to filter our packets so that we're only looking at the UDP data packets that are being sent. So I'm going to add all those configurations right now. This is any submodule that has radio is going to do the display communication range as true. Then we have our visualizer that displays our signals. Then we have our visualizer's physical link that displays our links, and then our packet filter so that we're only looking at anything that fits UDP data. Let's run this code. So right off the bat, you can see the communication range for host A and host B. I zoomed out a little bit so that you can see it a little bit better. Here's host A, its communication range is 500 meters, and here's host B, its communication range is 500 meters, so they're able to overlap with each other. We can make this smaller, they could still overlap though. If we run this, it's going to get really fun. Now we are going to see our signals propagate. Here's our radio signals going out and propagating. You can see the connection with our UDP signal being sent out. The green arrow that we just saw shows that there was a successful connection. To be sure that you understand, this circle right here that's displaying the communication range displays the circle around the host where it represents the maximum distance where a successful transmission is still possible. This propagation that we are seeing here, that is enabled by our display signals parameter for the medium canvas. It displays our transmissions as colored rings, as you can see, emanating from the host. In this case, host B is the one sending the information. Host A is the one sending the information. Of course, if we run this in Express, we won't see any of this animation. It kind of pauses until the simulation is done. So now we have learned how to create visualization of our communication. So the last step that we need to do is make these hosts move and have them still communicate with each other. So in the INET framework, a node's mobility is handled by the mobility submodule under hosts. So our wireless host, which extends standard host, has the mobility module. We can turn on mobility just in our omnet.ini file. So for everything under our network, we're going to access our host. Now we can say host everything and then access their mobility. Let's say we're only going to make host A move, which means that host A is going to send a signal to host B, and eventually it will go out of range of host B. So host A dot mobility, and we're going to set the type name. In this case, the mobility's type, we're going to just make it a linear mobility, which means it just moves in a straight line. So type name equals linear mobility. There's other types of mobility in INET. For example, there is circular mobility, which moves around in a circle. Then there's rectangle mobility, tractor mobility, vehicle mobility, which moves similarly to a vehicle. Then there's some other types of mobility as well. Those are the deterministic. Then there's trace-based. Then, like Veins, introduces their own form of mobility, which is the tracy mobility. So very simple though, right? We're just learning how to make a moving host communicate. We just add our linear mobility. Then we need to set the speed. asterisk dot host a dot mobility speed is equal, and we're gonna say 12 meters per second. So that's about 26 miles per hour and change. It's not moving too fast. And then we want to say like the initial movement. Where is it initially moving? This is in degrees. So we're going to say our host A's mobility. And then host A's initial movement heading is 200 degrees. Let's also have our visualizer display the velocity as well as the movement trails. So I'm going to add two new properties. So this is visualizer for our mobility, it's displaying velocities, and then it's displaying the movement trails as well. Now before we run this, let's extend our simulation time a little bit so that we can watch what happens a little longer. So I'm going to run our wireless network. I moved it up to 60 seconds. And if we run this code, we see that host A is slowly moving. Now we're not going to see it really quickly. It takes a long time, so we're going to speed it up a little bit. Post B, you can see the connection occurring, and then the connection breaks because it moves out of the range. And now we have finished our simulation time. So congratulations, you have just learned how to make a mobile host communicate wirelessly using OMNET++. Please remember to subscribe to my YouTube channel if you want to get alerted on more OMNET++ tutorials or any other tutorials that I do as well.